Okay, we're gonna see how cameras work in Unity. So here we have, this is the model answer for Labs 1.3 for the rollable. And when this is the completed one, we have a camera, we have the player and different items to be picked up, okay? So we have the camera for the game, which is shown here on the scene. This is the view of the game. And this here is the view, what this camera, when it's selected, is rendering. Okay, so nothing weird so far. Obviously, we take a look at the particular inspector, we can see the different things that the camera has. So we're going to be playing with some of these values. One of the first one to check is that essentially we have what we mentioned before, we have these clipping planes, right? So if you take a look at the scene, you can see how this there is this pyramid here that shows the frustum of the camera. Okay, and as I mentioned before, you can play with the near and far planes to indicate what's going to be rendering the game. So if I move near, for instance, if I start getting a higher value, then you can see over here that the near plane gets farther and farther from the position of the camera, and it comes to a point when it just reaches the actual objects on the scene and it stops rendering for the game the parts that are between the camera and the near plane. Okay, so basically you can move this as far as you can and you might not be showing anything. And if you see here, everything in this case is beyond the frustum is beyond the objects in the game. Okay, I'm going to set this back to 0.3 because that's the original value. And then we have the far plane. Obviously, the far plane is the other one. Normally, the default value is 1000, so that's actually quite far. I could be just making this smaller, but that's going to take me quite some time. So I'm just going to set it to maybe 100. Now, this still is beyond, this far plane is beyond the objects, but I can move it further and further until I reach where the objects are, right? Something between 20 and 10 affects everything. All the objects that we have here, and essentially what we have at this point is this plane is cutting through the objects, and as you can see, some things are not drawn in the game. Okay, so set it back to 100. Obviously, the farther the far plane, the more computational especially it's going to be to render all the objects in your game. But if it's too close to the camera, then what happens is that as you move the camera, some things will not very realistically pop up out of nowhere. Okay? Some games reduce the clipping plane, the far clipping plane, to have a better performance, but then they have the problem of things popping up. And in this case, what some people do is to include some fog at the end to diminish or reduce the effect of having these problems when using a near far plane. Some of the things that we can modify over here is this field of view parameter. This, as I said, this shows this angle, the angle of this pyramid. So as you can see, just changing this shows different render possibilities. For a very wide field of view, where this pyramid is almost a plane, or for a very narrow one, when you essentially are losing quite a bit of what's around to where this camera is looking at. Okay, and I put it back to 60. Another important thing is the projection. So as I mentioned before, you have two types: perspective and orthographic. So perspective is the typical one that you have for 3D games, and you can see the frustum and the pyramidal shape. If you change this to orthographic, you can see that automatically this changes to a cube shape. So in this case, the near and the far plane are parallel and of the same size. And you can actually modify the size with this variable over here. So for a projection, you can modify the size of these cubes and then create different perspectives. Obviously, you can see here is that we have completely lost perspective. In a proper perspective, you should see, even in this case maybe it's too subtle, but you should see in a perspective projection that this item over here is drawn larger because it's closer to the camera than this item over here. Whereas in this case, with the orthographic perspective, they are actually drawn the same. Okay, we can set back to perspective, and as I said, maybe it's not very noticeable, but this one will be shown slightly larger than this one because it's closer to the camera.